In project 3, we're going to take a look at the PMT function, which is the monthly payment function, and the FV function, which is future value. And they describe both of those at the bottom of page 51, and the actual project itself begins on page 52. And then we'll also look in project 3 at the now function and the date function. So there's a couple of new functions there that we'll see used in our workbooks. I've already opened up the RP reports file for project 3A, and I've already renamed it as they've suggested, so that's already been done. And you'll notice on our worksheet that this is Real Photography is the name of the corporation or the company, and the owner is trying to determine what the monthly payments are going to be for 3 models of equipment. And we're going to use the monthly payment function to determine what that is. Very similar to a monthly payment function that you might have for a car or a home, anything that you've borrowed money for. When you call a financial institution or a bank, you've got to give them the purchase price or the amount that you're wanting to borrow. They'll give you an interest rate as to how much they're going to charge for lending you that money, and then you'll also have a length of time in which you have to pay off that monthly payment. All 3 of these are in terms of months, 60 months, which would essentially be 5 years. So you need all 3 of these factors in order to determine what the monthly payment is going to be. With that, the monthly payment function again is found in your function dialog box. So you can either go to the Formulas tab, choose Insert Function, you can use the FX, you can go to Financial. If you look through there, you'll see, if you scroll down far enough, you'll see the PMT function. Any of these ways will get you to the Functions dialog box and allow you to put in the arguments for the PMT function. For our purposes in Chapter 2, we are only going to look at the 3 boxes that are in bold. Don't have to worry about the FV or the type. I also want to point out to you, in any dialog box that you're in, where your insertion point is located, it'll describe to you at the bottom what it's looking for. If I click in the NPR, it's telling you that it wants the number of payments for the loan, and then PV is the amount of loan, or the amount that you're going to be borrowing. So we're going to start out with a rate. And again, I'm pointing and clicking in the cells that represent the rate, the months, and then the actual amount that's going to be borrowed. So for the rate, move this out of the way. The rate is found for the first one in cell C5. And again, when you call a bank or financial institution, they're going to give you an interest rate that's annual percentage rate, or the APR. And for our purposes, when you determine what the monthly payment is, you need to convert the annual rate to a monthly rate. And to do that, simply divide by 12, since there are 12 months in a year. Then the NPR is the number of times that you're going to make that payment. And again, this is for 60 months. So I'm just going to click in the cell that has the 60 in it. Again, since it's already in months, you're fine there. But if we were trying to determine what the years were, like if we had years in here, if that was 5 years, then we'd take the 5 times 12 to convert it to months. And then finally, the amount borrowed is found in cell B5. Now if you'll notice, by default it comes up as a negative number, which in essence it is something that you owe, so it is negative. However, in the cell itself we want it to be returned as a positive number. So to convert that to a positive number, you simply put a minus sign in front of the amount borrowed, and you'll see immediately that's converted it to a positive number. Go ahead and click OK out of that. And you'll see that the monthly payment is $316.98. Okay, that same formula essentially needs to be included for the remaining 2 pieces of equipment. So we'll use the fill handle to copy that down. Immediately see, and again, if you want to look at the formula bar, you'll see that it's changed relative to whatever row it's in. Then for the total payments for the first piece of equipment, we're going to be paying this monthly payment for 60 months. So we want to determine what the total amount is for those payments. So again, this is going to be a formula that simply multiplies the monthly payment by the number of months. So we'll start out with an equal sign. And again, you're going to point and click where the monthly payments are located, which is in cell E5. Then we're going to multiply that times 60 months. Press enter. It's going to cost, well, we'll be paying out $19,018.82 for the first piece of equipment. Again, we want to copy that formula down. You can see the various formulas there and how they've changed relative to the row that it's in. And then we want to determine what the interest is. And your interest essentially is the total amount that you spend minus the purchase price. The rest of it will be the interest that you're paying. So again, we want a formula to determine this. And I'm going to start out with an equal sign. Click in cell F5, which is where your total payments is located, minus the purchase price. So you're paying $3,568.82 for the first piece of equipment. And again, we want to fill down, and this will determine the total interest that's being paid on the remaining two pieces of equipment. Okay, so that's the payment function, determining what the monthly payment's going to be. And again, a great what-if analysis. If you decide that the interest rate, maybe you'll find another bank that's going to give you a better interest rate. If you type in, let's say 6%, now what's your monthly payment, how that changes? It should go down because we get a better interest rate. But if I type in 6%, then the monthly payment will drop to $298. Okay, and if you wanted to copy that formula down to reflect, you would have to change each of these to 6%. And that would automatically update your monthly payments. Okay, so great tool for the what-if analysis as well. Now I'm going to undo to bring back the 8.5%. And then we'll move on to another function, the FV function, which is future value. And what the FV, or the future value function, will do for us is it will calculate the future value of a series of payments, equal payments. So if you had $100 and you wanted to know how much that would be worth after 10 years or whatever, you can use the FV function to determine that. And you probably have heard the term annuity. This is the same concept. But it'll determine how much money you'll earn after a certain period of time over a specific period of time at a certain rate. So if you get 5% for 5 years, then it'll determine what $1,000 investment would return after those 5 years. So we're going to look at the next section of the worksheet to determine that. In this case, we're looking at a monthly payment where we've got $1,200 that we have coming in each month that we're going to apply to this investment. We plan to do it for 36 months, which is 3 years, and we're going to receive a 9% return, which is pretty high for now. But the future value, we're going to use the FV function. So I'm going to go to the cell where I want the result to be displayed, and I'm going to go through the FX on my formula bar. And let's say I don't know what category it's in. I'm just going to click on all. If I click down in the list and type in an F, it'll take me to all the F functions. And we're looking for future value, which is right here, FV. I'm going to double click on that. That'll bring in the arguments. And again, we're looking for our rate. This is an annual rate. Again, we're going to be putting in a monthly amount. So we need to convert that to months. So I'm going to divide by 12. The number of months that we're going to put in the $1,200 is for 36 months. So we don't have to convert that. It's already in months. And then the amount is the $1,200. We do not have to put a minus sign in front of that since it's already a negative number. Okay, and you'll see immediately here what the result's going to be. I'll click OK. So after 3 years at 9% interest, if we put in $1,200, we should see $49,383.26. Now, the beauty of this is to kind of do a what-if analysis. What if we don't have $1,200, but maybe we have $100? We put in $100 every month. I should have put in minus. That would make that a positive. We would get $4,115 after 3 years. The book asks that we change that a little bit. I'm going to undo this. We've got $1,200, but the amount of time that we're able to put it in is dropping down to 2 years. So change that to 24. Notice how that drops to $31,426.16. So a lot of what if things. What if we can't get a 9% interest rate? What if it goes down to 5%? You can see how that affects how much you'll get in return after, in this case, 2 years. Okay. Next, we're going to take a look at the now and the date functions. I'm going to scroll down just a little bit here. Still using the worksheet here. In cell D20, we want to put in the purchase date for each one of these accounts. Evidently, these customers have purchased something. We want to put in the date in which they purchased it. And then what we're going to do is use that date in a calculation that will determine what the due date is. If you'll notice, each one of these customers have different terms on which they have to pay their bill. The first one gets 30 days before their bill's due, the middle two get 15 days, and the last person gets 30 days before the bill's due. So by using the date function, we can use that date in a calculation. If you were just to type in today's date, whatever that might be, that cannot be used in a calculation. Even though it would display as a date in the cell, you won't be able to use that in a calculation such as what we want to do here. We want to take the purchase date and add 30 days in order to see what the due date's going to be. Okay, so in cell D5, we're going to use, like I said, the date function. We'll go up to the date and time and click on date. The year that they want us to use here is 2012. The month is March, and the day is going to be 12. So March 12, 2012. Okay. Pound signs represent that the column's not wide enough to see the contents. So I'm going to go between D and E and double click, and that'll widen that column so I can see the date in the cell. And then the remaining dates, go to those. Again, the year is going to be 2012. The month for the second one is still going to be March, but the day is going to be 19. $2012 for the third customer. The month this time is still March, and it's the 26th. And then the last one is April 2nd. Okay, so you can see all the dates located in here. Now the due date is simply going to be the purchase date plus the number that's in the terms column. So it's a formula. We're going to start with an equal sign. Take the purchase date plus the number of days that they have to pay it off, and then we'll press enter. So their due date is April 11th. It's 30 days after March 12th. And that formula needs to go all the way down. So we can see 15 days after March 19th is April 3rd, and so forth. You can kind of see when the due dates are going to appear. All right, and then we're going to drop down to cell A27. In A27, well, A26, they want your name to appear. You could type that in, and then right below that in A27, they want the current date and time to be added to the worksheet. And what that will do for us is keep whatever day and time is on your computer. So if we save this file, bring it up tomorrow, it'll bring up tomorrow's date and time whenever you open up your workbook. So the now function, pretty simple. Well, we'll just leave that date and time, but I'm going to click in the list below and type in an N. Brings up the now function. It says returns the current date time formatted. This function takes no arguments. Notice the option here is equal now left and right parenthesis. You could have simply typed that in. It's pretty easy, but I just wanted you to kind of see what would happen too when you bring up the function dialog box. It doesn't have any arguments in it. So you still have to have the parentheses because that's part of the syntax and what's appropriate for a function. It always has to start out with an equal sign, name of the function, and then left and right parenthesis. So go ahead and click OK to that. Notice you're going to get the current date and the time in which the computer has housed. So and then if you'd bring it up again, like tomorrow, it'd say May 28th. If you brought it up the next day, May 29th, and whatever time that you brought the workbook open. Again, we'll go back and save the file before starting in Project 4.